Hello friends, we are again here to solve one of the classic problem available in SPOTS prime 1 prime generator. So the problem statement, I will not go again in detail. The problem statement says if there are two numbers m and n, this is the criteria of the numbers, then generate all the primes p between m and n including m and n. So let us begin that how to crack out this problem. So in this case they are also asking you to print individual numbers. So if you'll see for the two test cases 1 to 10, so the prime numbers are 2, 3, 5, 7, and between 3 to 5 including 3 and 5 the numbers are 4 is not a prime. So this is 3 and 5. Now let's look, before going deep into this problem we'll start looking into how to generate the sieve in this case. So what is this? So basically there is an algorithm existing which is called sieve. It's a Greek algorithm, pretty old long way of finding out the primes, which tells you that how to find out the primes between number 1 to n, where n is any natural number. But the interesting fact here is this, that the algorithm was designed for the numbers beginning from 1. So let's have a look. So now let's say we are interested to figure out the prime between 1 to 20. So in order to figure out that whether a number is prime or not a prime, we'll run the sieve algorithm here and see that how it helps us to find out the prime. So assuming we have created an array of 20, we are interested to figure out the prime number of 1 to 20, and assuming we have created an array of 20 elements, okay, and there is one more associated array which tells you that whether a given number is prime by yes and no. So I'm using y for a yes and n for no, and based upon that you can print out that what are the primes available from 1 to 20 or any number 1 to n. The exercise remains the same. So let's begin. From we mark 1 to 20 here, displaying number, and assuming initially all the numbers are prime except 1, because 1 is not a prime number. Now we'll iterate this array from 1 to 20. So we have found that the next prime is 2. Y means 2 is a prime. So any multiple of a prime is not a prime. So we'll start looking for the multiple of 2 in the whole up to the length of 20, within the limit of 20, and mark it out as not a prime. So here 2 is a prime, but 4 cannot be a prime. So let's mark it no. 6 again cannot be a prime. Let's mark is no. 8 again cannot be a prime. Let's mark is no. Similar way 10, 12, 14, 16, 18 and 20. Now let's further iterate in the array. 3 is again coming as a prime. So no multiple of a prime can be prime. So let's iterate in the loop and mark all the element multiple of 3 as not a prime. So 6 cannot be a prime. It is already marked due to 2, 8, 3, 6, 9. 9 cannot be a prime because it's a multiple of this. 15, so basically 6, 9, 12, 15, 18 are not prime. Similar way we'll go 4. 4 is already marked not a prime, so we'll not do anything for this. 5 is again a prime, so we will say the multiple of a prime cannot be a prime. So we'll look and figure out its multiple. So 10 cannot be a prime, 15 cannot be a prime, 20 cannot be a prime. Similar way for 6 has been already marked not a prime, so we'll not do anything. 7 has been a prime. Now the multiple of prime cannot be prime, so 14 cannot be. Similar way 8 is already marked not a prime. 9 is already marked, 10 is already marked, 11 is again a prime. Multiple of a prime cannot be prime, but 11 to 22, 22 is not available within the range, so we have nothing to do. 12, 13, 13 is again 2 2 we don't do anything for this. 14, 15, 16, 17 again, 17 2 times is outside the range, and 19 again. So now basically we have figured out the prime. So if I write this here, so I will say the total number of primes between 1 to 20 is 2, 3, 5, 7, 11, 13, 17 and 19. So basically now we have figured out how to figure out the primes in a given range from 1 to 20. Now let's say we are generalizing it for a set of 1 to n. Then what are the numbers existing as prime and what are not the primes? So we'll look out a smart code for this, which is quite small in length. So here we are assuming public static boolean generate c int a. So we are saying we will give you an integer and you have to figure out all the primes from 1 to a. So assuming we are creating, we will return out a boolean array which will say that whether a given number I is prime or not by true or false as a boolean index. So we say initially that initialize an array of length a plus 1, since array initializes from 0, hence we are initializing it up to a plus 1. Now we are saying for all the numbers for this, we are saying that all the numbers are prime, which means like the earlier way we did while doing the iteration. So all the numbers from 2 to 20 is prime. Then we are starting from the beginning number up to the length of the array. And we say that if the given number is prime, which means if it is yes, go within the array set up to length k and mark all the multiples of this given number as false. So this iteration we keep on doing for all the elements, and in the return we are simply returning is prime. So basically this is one of the fundamental portion, part 1 for to understand is prime problem, that how to generate a prime between 1 to n. So now you have figured out that for any number a, boolean I is a prime is indicated by, so I is a prime depending upon the boolean I is true or false. That's all for this. Thank you.